Scenario. A sphere is hanging from a light cord. It is swung so that the sphere of mass m travels with a speed v0 to the right on a horizontal surface with negligible friction towards a block of mass 2m. The sphere collides elastically with the block. Question. Describe the speed and the direction of the sphere a short time after the collision. Describe this using math. So you're going to be computing something here. The approach here is to use both conservation of energy and momentum of an elastic collision. So this is conservation of energy for two objects. This is the conservation of momentum of the collision between two objects of an elastic collision. All right. There are some things that are zero here, okay, because the block was initially at rest, so it's zero. You don't need to memorize this, but it does break down to this equation when you solve for it. Once you do systems of equations, you should come up with this. The final velocity is equal to a ratio of the mass times the initial velocity here. Okay? So, this is a very interesting idea. Okay? So, on the bottom, it is the masses added together. So, that is your summation of the masses of the system. On top, it's mass 1 minus mass 2. So, here, it would be 2m minus the m. So, here, once the block hits it, it's going to go to the left at basically mass divided by 3 mass. Or you could say 1/3 the velocity naught. The reason why it goes to the left is because of the negative sign when you do this. Or you could see that it's not strong enough to move to the right, so it moves towards the left. All right. Next, describe the speed and direction of the block a short time after its collision. Well, that one would be 2m1 divided by m1 plus m2 times the initial velocity, because the initial velocity was v0. Okay? Notice it is 2m divided by 3m. Remember, the momentum is conserved. So originally it is mass divided by 3 mass v0. That's its initial. Okay? So one part of it. The other part has to be 2/3. Does that make sense? Because take a look. This is 1/3 mass times velocity, right? That's what I'm trying to get you to look at. It's 1/3. So this is 1/3 of its momentum. This is the 2/3 of the momentum. Because in total, it should be 1/3 momentum plus 2/3 momentum equals 1/2 of the momentum. All right, so it was split here. But I said that the block here is going to go to the right at 2m divided by 3m. You could just write it as 2/3. But technically, it's slightly less because during the collision, in theory, things are lost because this is a inelastic collision. So some energy is lost. That's why it's slightly less. Okay? So when you do this problem, don't freak out about looking or deriving the equation. Just remember that the objects here are going to bounce to the individual side. So the sphere is going to go left, the block is going to go to the right, and they're going to share a total momentum of 1p. Okay, and it's split out from there. All right, there you go.